Good morning, everybody. I'm David Rubin with PG&E. I got here partway through the morning, so it sounds like you've heard a lot about us already. I don't need to really say a whole lot more, so maybe I can give my 15 minutes up and we can move forward with the panel. Does that work? Yes, no. I mean, all right, fine. I know most people are familiar with PG&E, so I'm not going to do much by way of a self-introduction. What I'm going to do is just talk about microgrids and the way that we are looking at them. And I've only got one slide, and I'll probably spend about 10 minutes plus or minus just kind of going through the details of this slide, and then have about 5 minutes for questions. And then if there are additional questions, I guess we can handle them as part of the panel that will follow. We use the Department of Energy definition on microgrids, which I'm going to paraphrase as a grouping of loads and resources that have the capability to operate at both in grid-connected as well as islanded mode. And I think the latter part of that, the islanded mode, does require us to really think and develop specific characteristics of a microgrid that can have the capability once the grid is down for whatever reason, and we work hard to minimize the amount of time that the grid is down, but outages occur, natural disasters occur, and we fully support the interests of our customers and our communities that want to be able to continue to operate through the next earthquake or the next major storm, if that's what happens. We support resiliency-related interests and efforts, and we also support low-carbon solutions to providing those types of resiliency outcomes. But again, it is a complicated engineering effort to be able to make sure that if you do have an islanded configuration, you can keep everything in balance as it needs to be for however long you're designing in order to operate during islanded mode. So the way that we tend to view microgrids is in 3 different configurations, and these are probably, I would say many of you in this audience will look at it and say, well, what about the following that may not fit neatly within either one of these 3? But by and large, the types of activities tend to fit fairly cleanly within 3 different areas. The first one that was mentioned a couple of times earlier is a single customer campus type of configuration. So the far left column includes those types of facilities, whether they're governmental entities, military bases, Silicon Valley campuses, healthcare facilities or healthcare complexes that are clearly needing to be able to ride through an outage and would have enough resources behind the single customer meter in order to allow it to at least operate it at some type of likely reduced load during an outage. Because typically these customers are not necessarily putting in as much as they need in order to operate at their pre-existing load levels, although again, it depends. And depending on the nature of the facilities, it may be that the loads are going to be quite a bit different during, say, natural disaster circumstances than they would normally be during grid connected. So for example, a school might become a collection point for residents within a particular area that could come together during a natural disaster in order to get food and shelter and hot water and charge their cell phones. And the load characteristics will be different likely than when that facility is operating as a school. But anyway, much of the activity falls within that first category, single customer facilities. The second category, which is relatively rare, but we do have a local example that we're working on, is for a community that is remote from the grid. So even though I said that we rely on the Department of Energy definition, which is a microgrid can operate in both grid connected as well as grid disconnected mode, the second category we're really looking at is operating 24/7, 365 in grid disconnected mode. So it might be an area that would be either today or in the future remote from the grid, and you need to have enough resources within the confines of that area in order to enable it to continue to be powered up all the time. So in California, there aren't very many of those places where you have a grouping of customers that are located remote from the grid. But to provide you with an example of a project that we're working on with a number of other partners, Angel Island, which is located in the middle of San Francisco Bay, not that far from here. Many of you hopefully have had a chance to visit there at some point in time, is connected to the mainland, to Tiburon, through a sub-bay cable that at some point is likely to fail. And if and when it does, likely when it does, it's a fairly sizable replacement cost. I think north of $5 million, but don't quote me on that number. And the load on the island is roughly about 100 kilowatts. So if you do math in your head, you can reach a conclusion that it may well just simply make much more sense to put on island capabilities in the form of clean generation and storage, and probably some rotating equipment that you're going to need in order to enable it to operate totally grid disconnected when that cable does fail. So instead of spending the money replacing the cable, we would look at having investments be on island in order to enable, again, a completely islanded operation for Angel Island. In fact, Alcatraz operates today in grid disconnected fashion. There's no cable that connects to Alcatraz. All the generation is on island. Much of it is diesel generation, as I understand it. It might be propane, but it's still, there's a little bit of clean energy generation, but much of it is rotating equipment. And then the final category, and Katie talked about this, Greg talked about it earlier, I believe I came in partway through the Oakland conversation, would be a collection of customers on grid that would operate, again, in grid disconnected fashion by way of putting in the appropriate sectionalizing equipment plus generation plus storage in order to allow a line segment that connects multiple customers to operate in islanded mode. We currently don't have any of these operating examples today. Katie had talked about the Berkeley project. That may go forward in a configuration that would have multiple customers be connected to a line segment. We are working also up in the Humboldt area with a project that was just recently announced as being awarded a grant from the California Energy Commission in order to look at an existing line segment that serves the Arcata Airport area. And there are a number of PG&E customers that are on that line segment. It's sort of an electrical cul-de-sac, so it ends at the airport. But there are a couple of other loads, I think about a total of 15 accounts, where we can, in fact, install sectionalizing equipment. And the Redwood Coast Energy Authority, that is the local community choice aggregation entity in that area, would be installing, I think, a couple megawatts worth of solar and then battery storage, so that in the event of the next outage or natural disaster, we could sectionalize that segment of line and it can remain powered up through the to-be-installed clean energy storage. And then there's also some additional existing diesel backup amongst a couple of the customers. So that project is really just getting started in terms of how we're going to go about working through the details associated with not only the design, but also how we set up tariffs in order to allow for the various types of commercial transactions that need to occur when that line segment is operated in islanded mode, right? Because all of the customers, and this gets back to the comments that Katie made earlier about some of the challenges of working with an existing line segment, we would need to get all the customers to essentially opt in to the arrangement. They would all be loads that would be part of the configuration, and we'd have to work out the details. Under blue sky conditions, it's not complicated, but when there is a grid outage and it's operated in islanded mode, the Redwood Coast Energy Authority would be providing supply through the solar and the storage. And so the question is, what are the, again, electrical and then associated commercial transfers amongst PG&E, the Redwood Coast Energy Authority, and the customers that would govern the arrangement during the islanded conditions, which again, we work hard to make sure are relatively limited in duration and extent, but we're designing for a resilient future that we all need to be thinking about as being different than the types of outages that we've experienced in the past. So these are three different examples or three different categories of the way that we view microgrids and think about how we tend to approach them in working with our customers and our communities in order to advance our common goal of, again, a carbon-free grid at some future point and greater resiliency in light of climate change induced types of natural disasters that we're really going to need to continue to be keeping in mind and preparing for as we move forward. So I think I kept myself pretty close to the 10-minute mark. I'm happy to take questions either now or when we're up on the panel. Thanks.
Those are great examples, David. Thank you. The Arcata Airport example is really at the heart of the Clean Coalition's community microgrid definition, and I have two questions about it. One is, there's been a discussion, Katie brought it up, and then you've reemphasized it, about needing to get permission from customers that would get turned off, or I think you even indicated that customers that would stay on also need to approve. I'm a little confused about that because I'm not aware of any regulations that in a grid outage where normally everybody would be off, that you would need to get permission for to keep some customers on that line segment on. Maybe you could just address whether there's actually a regulation, or is this just kind of a extra precaution that PG&E is kind of taking in its own corporate policies, and then I've got a follow-up question to that.
Okay. So thanks. So what I didn't mention, but was kind of implied, but it's appropriate to kind of talk about, is the fact that, again, these customers are going to be getting an additional measure of reliability, right, as a result of the fact that the line segment will remain energized, and there are costs associated with having the capability to provide that extra measure of resiliency. So we anticipate, and again, we haven't worked through the details with the other project partners yet, that some of the costs are going to be paid for through the CEC grant, and there may be other costs that would need to be included, and similar in some sense to when we have a group of customers that want to underline their utility facilities in a community, they all need to kind of opt in, and then there are costs associated with performing the undergrounding work. In this particular case, it would be somewhat similar. So if a customer, let's just say one of the customers didn't want to be part of the arrangement and whatever costs are associated with the additional investment that's required, then they could opt out, but then we're faced with the same challenge that Katie mentioned earlier. Now, in this case, it's a relatively small number of customers. In downtown Berkeley, you have a large number of customers that are interspersed between the buildings that the city wants to maintain as energized. And so we do have, as a tariff matter, if a particular customer chooses to not be part of the configuration, to inform them and then figure out a way to actually disconnect them, right? So again, it's sort of a collective group of customers that are part of a non-standard configuration. They all have to either opt in, or if they're not in, then we have to figure out how we're going to operationalize it.
So it's a business issue, not a regulatory one. Is that the answer?
Almost all of our business issues become regulatory issues at some level.
Okay, but not there's no existing statute that would prevent this from happening. It's more of getting the business model right. I think is what you're saying.
I mean, again, I'm not an attorney. I don't think there's anything in statute in particular, but anything that we offer to our customers are part of a tariff that ultimately is approved by the Public Utilities Commission that defines the terms and conditions.
Follow-up question is a little bit easier. Thank you for addressing that, by the way. The second question is, I think you described in Arcata Airport that the operational control in a grid outage would be handed over to the CCA, and that seems interesting to me, that you would give them control of your distribution line segment.
Sorry, if I had, so I don't think I said that. If I did say it,
that's how I interpreted it. Sorry. Could you clarify how that operational control, who's in control when the grid goes down, and if anything hands over to anybody else for PG&E, how that happens?
Sure. So this, again, is something that's being worked out as part of the project. I'm not as directly involved in that particular element of it, but I can give you kind of a high-level overview. And if I start to mix concepts, it's probably because I'm outside my bounds of knowledge. But certainly it would be true that the battery and the generation would be directly under the control of the Redwood Coast Energy Authority. we would still be responsible for the operational characteristics of that line segment. There are assets. So we would set the parameters that would be used as a basis for setting the controls on the battery, essentially the battery system. How we ultimately end up, though, having that level of control operationalized in real time, what types of visibility and control capabilities we work our way back to our distribution control center that'll be remote, are still details that are being worked out. We do have a proposal under PG&E's share of the EPIC funding in order to be able to sort of develop the back end part of that arrangement. So no, we would not be ceding the operational control of that line segment over to Redwood Coast, but we'd be working with them in order to ensure that the voltage, the other reliability characteristics of the line segment are maintained within the appropriate parameters. Yeah, sure. Do you want to take one more and then go to the panel? Or? Okay.
Going back to his first question, you were talking about, I guess, tariffs for this resiliency. Would that still apply in a situation like the Angel Island, where you are, I guess, deferring T&D costs to add this resiliency?
So the answer to that question is not quite in the same way, and you've raised a very good point that I appreciate you bringing up, because the way that we're looking at the second category, so I keep on pointing to the screen, but you can't see what I'm pointing at. The second category over here is that it's sort of normal tariff utility service, right? Because we're just choosing to provide regulated service in a different way than we otherwise might be. The normal way would be to connect customers to the grid, but there are clearly going to be some cases where it's just more sensible to not do it that way. So we're not anticipating that there would be a cost differential. The customers would still be paying, and this is the state, by the way, that owns the facilities. If they would still be paying according to tariff rates, Marin Clean Energy will likely be the ones providing the on-island clean generation, because this is within their CCA area, and the state's sorry, I can't say anything about customers. Let me just step back from that. If the state were a customer of Marin Clean Energy, then there would need to be some sort of perhaps arrangement, but none of that really has been worked out to date. But to your question, we don't see this as being in the same general frame as the third category, because it's really clearly something that we're going to want to make sure customers are comfortable with, but it's a way of us providing regulated utility service as opposed to a group of customers wanting a different form of that service. Does that help? Yeah, thanks.
All right, we have one last presentation before our panel with Brendan McEaney from the USGBC. Is that good? Close? All right. I tried.